Hello everybody. So today we are looking at the grade 9 type questions. This is a few questions that we can expect. We already started with the first two. I'm just going to do it again. I'm going to do number 1 again. So what is important when we're doing addition and subtraction of fractions is we need to make sure that the denominators are the same, and we use the term or the LCD. So there we have 3 over 4 plus 1 over 8 and minus 1 over 2. Now my LCD here is 8, so I need to make sure all of these denominators are 8. So I need to multiply by 2, but what I do in the bottom, I repeat on the top. Here, with that one, I don't need to change. Here, I need to multiply by 4, and there I need to multiply by 4 as well. I'm quickly going to do that and rewrite this. So that's going to be 6 over 8 plus 1 over 8 minus 4 over 8. Now I can just write my answer over 8. So that 6 plus 1 is equals to 7, minus 3 is equals, minus 4 is equals to 3. Well done. Okay. The second one there that we had was number 2. We have the first two is common fractions. So I'm just going to do the conversion. How do I do the conversion? I say 2 times 3 plus the numerator. So 2 times 3 is equals to 6, right? So 6 plus 1 is equals to 7 over 2. Then I have 4 times 2 is equals to 8. 8 plus 1 is equals to 9 over 4. And then plus 4 over 1. I go identify the LCD. The LCD right here is 4. So I need to make sure all of them is written over 4. Here I need to multiply by 2. But what I do in the denominator, I need to repeat in the numerator as well. So I'm going to multiply that by 2 as well. Then this one is already 4, so I don't need to change anything there. This one is 1. What can I multiply with? I can multiply by 4. But if I multiply here, I need to multiply on top as well. Alright? So let's go rewrite this. This is now going to be 14 over 4 minus 9 over 4 plus 16 over 4. Alright, so then we can write the answer over 4. So that's 14 minus 9. Great stuff. She says that the answer is 5. Alright, 5 plus 16 is equals to 21. So that is my answer, 21 over 4. I can leave it like that, or I can write it as a mixed fraction. So that is going to be, how many times is 21 going to 4? 5 times, and there's a remainder of a quarter. Alright, so it's 5 and 1 quarter that remains. Yes. Probably like 2 and 3. 2 to 3 can, depending on how the difficulty of the question. Question number 3. It depends on whether they ask you to do it if they ask you to do it on a calculator, it's probably just going to do 1 mark. If they ask you without the calculator, then you need to show your all working, then it can be more marks. Alright? Please show your working clearly. What do I have there is negative 6. I'm going to do the negative 6.5. I'm going to convert it. So that's going to be 2 times 6, which equals to 12. And gets me to negative 13 over 2 minus 4, 5. 5 over 2 all over negative 13 over 2 plus 5 over 2. Right, so we're first going to simplify the top part. No, that now becomes negative 13 minus 5 is negative 18 over 2. Divide by 13, negative 13 plus 5, negative 8 over 2. Now if I have a fraction divide by a fraction. No? So it doesn't look nice. I'm just going to rewrite this. I'm not going to change anything. It's technically negative 18 over 2 multiplied by, sorry, first division, divided by negative 8 over 2. What I can do now, if I'm doing division of fractions, I can multiply with a reciprocal. Ever heard of that word? Just means the inverse. So that means I'm going to say negative 18 over 2 times 2 over negative 8, and then that one and that one cancels out, so I'm left there with negative 18 over negative 8, which equals to 9 over 4. That negative and that negative cancel out, so I have the 9 over 4, and I can rewrite this as 2 and a quarter. That's my final answer. Okay, two more to go. Question number 4. These questions would most probably be, if I was the examiner, I would ask this without the use of a calculator. Alright, so that's 2 minus a quarter, 1 and a quarter, sorry, to the power of 3. We keep everything under the square root first. What I'm going to do, I'm going to solve the brackets first. So that's going to be 1 over 3, 2 minus, alright, so I need to first convert this. That's going to be 2 minus 4 times 1 plus 1 is equals to 5 over 4. I have the 2 over 1. Alright, everyone's with me? Now I change the denominator to 4. So now I'm going to get 1 over 3. That becomes 8 over 4 minus 5. So what is 8 minus 5? That becomes 3 over 4 to the power of 3. No? So what does that to the power of 3 mean? I'm just going to do this to the side. That 3 over 4 to the power of 3 means 3 over 4 times with himself 3 times. So what we can say, it's going to be 3 times 3 times 3, which equals to 9, and then 4 times 4 times 4. 4 times 4 is equals to 16. 16 times 64, alright? 27. 27. Good. So we have 1 over 3 times with 27 over 64. Now I can see 3 goes into himself. How many times? Once. It goes into 27. 9 times. So I have technically here under the square root 9 over 64. So now I can go write it as the square root of 9 over the square root of 64. What is the square root of 9 again? 3. Square root of 64. Square root 8. Okay. So first step that I have here starts here. No? Is I'm first going to here we have 2, but I'm going to first convert this is a mixed fraction. I'm going to do improper fraction. You know how to do that. So I'm going to say 4 times 1 plus that 1 on top is equals to 5. Now I have here 2 minus 5 over 4. But I have a integer and a fraction. So I convert both to fractions. So I write 2 over 1. But my LCD there is 4. So now I change this, but I'm going to change this. I need to do it on top as well. Alright, so the 1 I changed to 4 by multiplying by 4. Now I need to repeat the same on top. So that gives me 8 over 4 minus 5 over 4. So 8 minus 5 is equals to 3 over 4. Everyone with me on that? Now, that was BODMAS. I will work with inside of the brackets first. Now I have the cube outside. What does a cube mean? It means the term or whatever is standing there multiplied with himself 3 times. Alright, so then I did this to the side and I said 3 times 3 is equals to 9 times 3 is equals to 27. Now I did that for the numerator. I'm going to do it for the denominator as well. So that means 4 times 4 is equals to 16. 16 times 4 is equals to 64. Alright, everyone with me? Up until there. That's how I got to this. Now I have within the bracket, I have 27 over 64. Alright, but so if I can ask you, simplify this for me. 1 over 3 times what? 27 over 64. You can go and say 1 times 27, but I saw here 3 as a common factor. Or I can take 3 out. No? So I say 3 goes into itself once, but it goes into 27 9 times. So that's why I simplify this. So I have 1 times 1 over 1 times with 9 over 64, which equates to 9 over 64. But this is still under the square root. Now, technically, I know what the square root of 9 is. I know what the square root of 64 is. No? So therefore, I just split it up, the two square roots, and I wrote down the answer. In the next one, I'm going to show you how we can do it on another example. Okay? Not another example, but on another way. Good. I'm going to do the last one now. All right, and I'm going to leave it on the board for you to write it down. So now we have 3 cube root of 1 over 32, and then 1 minus 3 over 4 to the power of 2. I'm going to go slowly. Try to stay with me. The cube root of 1 over 32 times with, I'm going to write that as a fraction. So it's 1 over 1 minus 3 over 4 squared. I first need to solve the brackets. Can I solve the brackets? We're doing subtraction of fractions, so we first need to change the denominators. So therefore I'm going to change the LCD that I identify here is 4. I'm going to change that to 4, so I'm going to multiply by 4 there and multiply by 4 there. So then I get 4 minus 3. It's 1 over 4. No? You got that? 4 minus 3 is equals to 1 over 4. So now I get this answer is here going to be the cube root of 1 over 32 times with 1 over 4 to the power of 2. I've been explaining the whole time. No? You just a little bit slow. Alright, so now what I'm going to do now, no? I don't know what is 32 times 4. Alright? So I'm going to simplify these numbers now. How can I simplify numbers that are big like this? I can simplify them. Oh no. What I first need to do here is I need to say 1 over 4 times what? 1 over 4. 1 times 1 is 1. 4 times 4, 16. Alright. Now what that means here, I have the cube root of 1 over 32 times what? 1 over 16. Alright, so, but this question they would most probably ask without the use of a calculator. And I am quite lazy, so I don't know what is 32 times 16. And I don't have time to write it out. So I'm going to teach you a secret. No? You learn stuff, or we as teachers show you stuff. You might not always understand why we teach you this. But you need to ask yourself that question. But why is Mr. Le Cordeur showing me this? So remember we had 32 and I asked you to prime factorize. If I go prime factorize 32, it's going to be 2 and then 16 and then 2 and then 8 and then 2 and then alright? So that means 2 to the power of 1, 2, 3, 4, 5 is equals to 32. No? Stay with me quickly. Now, so 2 to the power of 5 is also equals to 32. So that means 2 to the power of 16 can also be written as 2 to the power of 4. I'm just going to rewrite this like that. So that's going to be the cube root of 1 over 30, not 32, 2 to the power of 5 times 1 to the power 2 of 4. Stick with me. Then I'm going to say denominator times the denominator, 1 times 1 equals to 1. 2 to the power of 5 times the 2 to the power of 4. The bases are the same, so I can add my exponents. 2 to the power of 9. Now, we can most say the that's going to be the cube root of 1 over the cube root of 2 to the power of 9. Alright? But because we have a cube root here we could have said 2, there's an invisible 2. But because we have 3 outside, we can say that now becomes 1 times what gives me 1? Just 1. Now I'm going to say this 3 and I'm going to divide it by that 9 inside. Then I get rid of the root. So that becomes 2 to the power of 9 divided by 3. What is 9 divided by 3? 3. So that means it's 1 over 2 to the power of 3. But 2 to the power of 3 means 2 times 2 times 2. 3 times. So that means it's 1 over 8. No? And there's my answer. How we could have done this otherwise, let's quickly check our calculator. Quickly. You have a calculator there with you? You can say 32 times with 16. Your answer is going to be the cube root of 1 over, is it 5 on 12? 32 times 16, no? 5 on 2. 5, 1, 2. Now you can say, what is the, put this as is on a calculator. So you're going to say the cube root of 1 over 5, 1, 2, 1 over 8. You see? But I'm going to ask you to do it without the calculator, so this is quite important. I thank you for watching the video, and until next time, see you again.